Today I'm going to talk about solving equations where there are like terms on the same side of the equals. Before I do that, I'm going to do a review of two-step equations to remind you of what we do. In this first example, two-step equation, there's a number being subtracted from the variable term. Your variable term is negative 8x. So I need to get rid of that minus 14 after it. After that, I'll divide by the coefficient of the variable term, which is negative 8. So to isolate the variable term first, I have to use an inverse operation, adding 14 to both sides. That leaves me with negative 8x equals 32. I've made a two-step equation a one-step equation. The next step and the last step is to divide by negative 8 because that's the coefficient. Remember, if your coefficient is a negative number, that's what you have to divide by. Dividing by positive 8 will give you the wrong answer. Negative 8 will give you the right answer. You should also remember to check your answers by plugging them into the calculator to see if the value of x works in the original equation. Here's another equation. Now, look at this one. Is it really a two-step equation? Not exactly. It's not, because there is a number being added with x right here, but x itself has a coefficient of positive 1. So the only step I have to take to solve this equation is to subtract 1 from both sides. There's a plus sign in front of the x. That means the coefficient is positive 1. And then I just combine the negative 4 and the negative 1 on the other side, and I'm finished. So that's a review of what the kind of equations we've been working on up to today look like. Take a look at this equation. What you're probably noticing is that you have the variable term in two places, and they're on the same side of the equals. That's important because later we'll look at equations where you can have a variable term on both sides. When you have like terms on the same side of the equals, you're going to combine them before you go on to the next step. Now, let's review that like terms mean the same variable to the same power. So, minus 7x and plus 8x are like terms. I can just put them together using my rules for integers. Since negative 7 plus 8 is positive 1, negative 7x plus 8x is equal to positive 1x. Now you might notice that this is the same equation that I started with in the last example. So subtract 1 from both sides. X is equal to negative 5, just like it was before. So there's an extra step here, but you still end up with an equation that looks like what we've been doing up to this point. Here's another example, and in this case, we still have like terms on the same side of the equals. I'm going to include that minus sign and just start calling that negative 2. Even though there's a 5 in between, these two like terms are on the same side of the equals, so they can be put together. The way they're put together is to say positive 1, the invisible 1, which is the x coefficient, put it together with a minus 2, and I'm left with a negative x. That came from putting the two like terms together. Don't want these in the way. Anything that didn't change for a reason just gets brought down to the next step. I didn't do anything to the 5, the equals, or the 6, so they are still part of what I need to hold on to here. Now I have a two-step equation again. Think about what the next thing that you think I'll do will be. I'm going to take 5 away from both sides. That leaves me with negative x equals 1. I don't care if you call this right here 6 minus 5 or 6 plus negative 5 because they mean the same thing. Either way you get 1, but remember that's not the final answer. I don't want to know what negative x is equal to. I want to know what x is equal to. So the coefficient is negative 1. I'll divide by negative 1. And that changes the sign of the final answer. That's an important change because the final answer is not positive 1, it's negative 1. Here's a little bit shorter equation, but there are still like terms on the same side. This time the variable's on the right side of the equals, and that's perfectly okay. Let's just keep it there. Coefficient of negative 1 on the first y, negative 3 on the second y. Put them together, and the new coefficient is negative 4. Since there's no constant on the same side as the variable, the only remaining step is to divide by the coefficient. I have one more example here to look at. This looks like a longer, more complicated equation, but all it is some like terms on the same side of the equals that need to be put together. Now I'll mark them up here, but you have to be careful when you're working on paper. If you write all over your paper, you might not be able to read the numbers after a while. But you can just lightly mark that I have an x term here and another x term that I've underlined there. 2x and 5x. Both of these x terms are positive. There's no sign in front of this 2, and the sign right in front of this 5 is a plus. The minus is on the 7, so we'll deal with that when we look at the constants. Positive 2x plus 5x adds up to 7x. And I'm still looking for like terms, because remember, all constants, numbers with no variable next to them, are also like terms. If you put minus 7 together with plus 8, you get plus 1. Don't worry about whether this is minus 7 or negative 7. If there's one minus sign in front of that 7, just start calling it negative 7. On the other side of the equals, we don't have a variable, but there are 2 constants that can be put together. 12 plus 3 adds up to 15. Now this is a 2-step equation. 7x plus 1 equals 15, just like 2-step equations that we've been working on for a little while. So the first step, inverse of adding 1, is to subtract 1. A 1-step equation with a variable having a coefficient that is not 1. Last step is divide by that coefficient. X equals 2. So to conclude, the only thing new about equations where you have like terms on the same side of the equation, that means either the left of the equals or like terms on the right of the equals, combine them first. When you combine like terms, use your rules for integers, which your calculator will take care of for you.